Many today think the universe is only built by tiny bits of matter, and all that exists is different arrangements of these particles. All your hopes and dreams are nothing more than the products of tiny atoms bouncing around. The fundamental nature of the universe and everything within is material, and all we see and know is nothing more than the emergent features of these tiny particles. But despite this, physicists are finding a different picture of reality. The old notions of materialism are fading away. Our universe doesn't appear to be material after all, but something emergent from a more fundamental underlying reality. Space-time and matter do not appear to be the foundation of reality, but an emergent construct of a deeper reality, and a new consensus in physics is emerging.
The future, at least of this development, will be that we start actually with information. So information is going to be our starting point. And space-time is not something that we start with. We forget about what space is and what time, and then somehow the information, by thinking about how much information is, what information is doing, then the space-time will, what we call, be emergent. It will come out of just a bunch of zeros and ones.
So the idea is that the concept of space, of distance, all the spatial concepts we deal with in science are emerging from that deeper level. They're not fundamental in the world. They're derivative.
In the hunt to rectify quantum mechanics with relativity, physicists discovered something known as the holographic principle, a theory which suggests the entire three-dimensional universe can be seen as two-dimensional information. In other words, the whole three-dimensional universe, the particles that make up reality, would emerge from underlying information in quantum field theory.
People finally began to articulate this new principle, this holographic principle. And what it said is that all the things that were falling inside a black hole were somehow captured in a preserved image at the horizon itself.
So if the information is not lost on the surface, the information is not lost inside because they are equivalent.
All the information about those objects, what they were like in their three-dimensional existence, was preserved or encoded on the surface of the black hole. And that's a little bit like a hologram.
Well, that suggests that maybe that idea may apply more broadly to the universe as a whole. Maybe the three-dimensional objects, us, everything in the world around us, maybe all of the information in these objects is carried, is smeared around a distant two-dimensional surface that surrounds us, and we're just in some sense a holographic projection of that distant data.
The holographic principle tells us something quite astonishing. It says that our ideas of volume, of the real world in a sense, might be a kind of illusion.
The holographic principle only worked in theory at first, with no observable data to back it. But all that changed in 2017, when a peer-reviewed study published observable evidence for the holographic principle. They tested the model against cosmological observations of the early universe and found that the holographic model is compatible with the data that is found in the cosmic microwave background radiation. From looking at irregularities in the background radiation, their team found that simple equations of quantum field theory could explain almost all the cosmological observations, is marginally a better fit than the standard model, and could potentially explain apparent anomalies. But this would mean evidence in the cosmic microwave background radiation infers three-dimensional reality is an emergent informational construct. Observable evidence infers reality as we experience is not fundamental, but emerges from the quantum realm. This piece of data only correlates to a study from later that same year, which points out entanglement is an inevitable feature of reality. Entanglement happens when two particles interact in a way that their quantum state or wave function cannot be described independently or without the other. However, if you were to separate them by a great distance, a change to one instantly affects the other. This has been demonstrated in several experiments, and now a new study shows that such a phenomena is an inevitable feature of reality. We show that any theory with a classical limit must contain entangled states, thus establishing entanglement as an inevitable feature of any theory superseding classical theory. In other words, any theory which purports to describe reality must include quantum entanglement as an underlying fundamental feature of reality. If you entangle two particles and separate them by a great distance, a change to one will instantly affect the other, regardless of the space between them. So the information between them doesn't seem to be affected by space, implying space is not fundamental for the underlying world of quantum mechanics, but an emergent phenomena of the classical world that only exists after measurement.
Whereas space is just obviously not fundamental. Space is something where when you go from classical mechanics to quantum mechanics, space more or less disappears. In classical mechanics, what do you have? Some particles moving through space with some velocity. In quantum mechanics, you have a wave function of all those particles. And that wave function, we tend to talk a language that the wave function is a function of all the particles and their locations in space, but we don't have to talk that language. We can use what is called the momentum space description. We can completely describe the particles by how fast they're moving instead of where they are in the universe. And for that matter, we don't need to use any description at all. We can just use these quantum mechanical states in their own right, with no reference to space whatsoever.
Remember that in quantum mechanics, prior to measurement, particles have no defined properties or locations. In the absence of measurement, particles simply exist as a wave function of possible states they could take, and that includes the location of the particles. If particles have no defined locations prior to measurement, that would mean the information between entangled particles exists other than spatially. Spatial location only emerges after measurement. Thus, entanglement shows space is not fundamental, but emergent from quantum processes, correlating with the evidence from the holographic principle. The wave function of entangled particles is far more fundamental than the space between them. Therefore, the underlying information is more fundamental, and space is emergent. Space is just the illusion that particles are separated, not a fundamental feature of reality. Physicist Sean Carroll writes on his blog, Space Emerging from Quantum Mechanics, that the most likely way to explain the nature of gravity is to note space emerges from quantum mechanics, not that space is a fundamental property of the subatomic world. Physicist Haiyan Seok Yang says emergent spacetime is the new fundamental paradigm for quantum gravity. This new paradigm suggests space is not fundamentally real, but emergent from the underlying quantum realm. But it is not just space that is emergent from quantum entanglement. Einstein demonstrated space and time are one, so that would have to mean that time is also emergent from the underlying quantum realm, and an experiment from 2013 reveals this. The Wheeler-DeWitt equation, which calculated the wave function of the universe, noted the time factor dropped out, meaning time is also not a fundamental aspect of the underlying quantum world, but emergent in the classical world that we experience day to day. And in 2013, an experiment seemed to confirm this idea that time, along with space, is an emergent phenomena.
So in quantum gravity now, probably what's going on is what we're seeing is that the whole notion of space and time is probably not really fundamental. So space...
That sounds incredible. That space and time is not fundamental. Space and time seem, in an ordinary sense, to be the most fundamental thing, and everything else seems to happen in space and time as sort of the fixed background.
Right. But what could be happening is that there are two different notions of time, a more fundamental one and an emergent one. So it's the emergent one that is part of the space-time, but there is a more fundamental one that makes sense without space.
Now, neither one of those new ways are obvious to us in our common perception, obviously, but Einstein put space and time together, which was a radical change. What you're saying is that the time that he might have unified with space may be an emergent time,
That's
and there's
right.
something more fundamental in time.
One.
Thus, all of what we experience, space, time, matter, all seem to be emergent constructs of the classical world, not fundamental aspects of reality. Experimental data shows us matter and spacetime are emergent, while in contrast, another experiment shows the wave function is fundamental to reality. At the advent of quantum mechanics, many suggested the wave function was not actually a part of nature, but just a mathematical tool which represents our lack of knowledge about the system. Yet a recent experiment gave strong evidence the wave function should directly correspond to reality. So the wave function, a mathematical probability of possible states in Hilbert space, does correspond to the fundamental nature of reality. space-time is nothing more than a construct emerging from the wave function in Hilbert space.
Space-time is not fundamental. The space-time is, if you like, an effective emergent description from something else.
The implications of this are quite astonishing, because the wave function is not a physical object extended through space, but a mathematical probability of where physical particles will appear in space. Sean Carroll explains, mathematically, wave functions are elements of a mathematical structure called Hilbert space. That means they are vectors. We can add quantum states together, the origin of superpositions in quantum mechanics, and calculate the angle or dot product between them. The word space in Hilbert space doesn't mean the good old three-dimensional space we walk through every day, or even the four-dimensional space-time of relativity. It's just math speak for a collection of things, in this case, possible quantum states of the universe. The underlying truth of the universe is a mathematical reality from which the classical world we experience emerges. What we think is objectively real is nothing more than an emergent construct of underlying mathematical informational processes. To further confirm this, Brian Whitworth looked at specific features of our universe and compared them to a virtual world. What he found was 11 key features of the universe are better explained with the idea of a virtual reality instead of an objective reality with fundamental space, time, and matter. Features of our universe, like the maximum speed, the Big Bang, quantum transitions, and wave function collapse, all make more sense in a virtual world. In other words, the philosophical conclusion is our universe behaves more like a virtual world instead of an objective reality. This aligns with the scientific data we just discussed, which shows space-time and matter are emergent. On top of this, the work in theoretical physics is leading us towards the conclusion the rules of physics and gravity are emergent from the underlying spaceless, timeless quantum realm. All the evidence infers that physical reality is not fundamental, but emergent from underlying information. But there is a much deeper implication here. The wave function explains the emergence of spacetime, but the same underlying mathematics has been seen to parallel conscious thought processes. Quantum superpositions do have a vague similarity to how we think and mentally operate. For example, we often hold conflicting positions simultaneously before making a final decision, like how the wave function is in a superposition of multiple states before final collapse to one definite outcome. We can bounce around between different ideas in our head, similarly to quantum tunneling. This similarity might be more interesting than we realize. In 2009, physicist Diederik Ertz took this one step further and published a paper noting that our cognitive processes can be readily modeled using the mathematical formalism of quantum mechanics. In other words, our inner mental world of thoughts, qualia, and emotions can be modeled in terms of Hilbert space and quantum processes, the same processes that give rise to space-time and matter. Many suggest this is just a coincidence, but there have been hints that it goes beyond this. Within the past few years, a number of papers have been published supporting quantum mind theory. Information processing has been reported to exist inside microtubules, and another study has shown that tubulin protein molecules self-assemble via quantum tunneling. We even have evidence to suggest that quantum vibrations are coming from microtubules. Quantum biology researcher Anirban Bandyopadhyay said the microtubule appears to be a fundamental information processing device in biology. More and more evidence keeps coming out supporting that there are quantum processes in the brain, cohering with the field of quantum cognition that the inner world of the mind should be modeled with the properties of quantum mechanics. This all suggests quantum cognition is not just a way to model cognitive processes, but directly applies to the very nature of the mind and the brain. Stuart Hameroff also points out that since the inner mental world of the mind can be modeled like the quantum world, the brain is more likely to be quantum computing instead of classically computing.
Okay, so quantum cognition is this mathematical approach, and from Wikipedia they say, well, the field clearly distinguishes itself from the quantum mind as it is not reliant on the hypothesis that there is something quantum mechanical about the brain. So they're trying to have their cake and eat it too. They're trying to say we're using quantum mathematics, but we don't want to go on that risky limb that there's quantum biology in the brain, because everybody knows the brain's too warm, wet, and noisy to have quantum computing going on. Nonetheless, some of us do feel that the brain has quantum biology, and it has to. And for example, if a classical system would try to simulate a quantum system, you'd have exponential slowdown, as Feynman showed. It would be, you wouldn't be able to do it. It would involve so much computation. And what would be the point of using a classical system in the brain to simulate a quantum system if you could have the quantum system?
Quantum cognition seems to fit with recent experimental data of quantum mind theory and recognizes the basic idea that our thoughts and emotions behave like quantum superpositions, not like physical objects or chemicals bouncing around inside our heads. Thus, the inner world of the mind, our thoughts, emotions, dreams, qualia, etc., would be distinct from the physical world, like how Hilbert space is distinct from space-time. In other words, there is a parallel distinction with the spaceless, non-physical reality of Hilbert space, from which space-time emerges, to how the spaceless, non-physical reality of our minds, our thoughts, emotions, dreams, is distinct from the external physical world. This is a common understanding with regards to the mind-matter distinction in philosophy of mind. No one can demonstrate how a mental phenomena would emerge from a physical substance. A feeling of pain can never be equated to an electrical signal. The mental experience of color cannot be equated to electromagnetic waves which hit receptors in our eyes. There is merely a correlation between the two, but one cannot explain how qualia could ever possibly emerge from this. As John Searle says, how does a mental reality, a world of consciousness, intentionality, and other mental phenomena fit into a world consisting entirely of physical particles and fields of force? Colin McGinn says, the problem with materialism is that it tries to construct the mind out of properties that refuse to add up to mentality. Thomas Nagel says, if a mental event really is a physical event, in the sense and nothing else, then the physical event by itself, once its properties are understood, should likewise be sufficient for the taste of sugar, the feeling of pain, or whatever it is supposed to be identical with. But it doesn't seem to be. It seems conceivable for any physical event there should be a physical event without any experience at all. Experience of taste seems to be something extra, contingently related to the brain state, something produced rather than constituted by the brain state. So it cannot be identical to the brain state in the way that water is identical to H2O. In other words, no amount of introspection can ever be reduced to the chemistry of the brain.
There's nothing about introspection that leads you to sense that your subjectivity is at all dependent or even related to voltage changes and chemical interactions going on inside your head. Okay, you can feel, you can drop acid, you can meditate for a year, you can do whatever you want to perturb your nervous system. You can feel yourself to be one with the universe, and at no point in that transformation do you get a glimpse that there's 100 trillion neurons in your head, or synapses in your head that are doing anything.
But what if we have it backwards? What if the problem is we think that mind arises from the brain, when in reality, what if the experience of the physical world arises from the mental world, correlating to how space-time emerges from Hilbert space? The correlates can no longer be ignored. The scientific evidence points to the fact that space-time and matter are emergent from the wave function in Hilbert space, and the inner world of consciousness and mind can be modeled as Hilbert space in the study of quantum cognition. Add on the evidence for quantum mind theory, and the most parsimonious explanation is space-time emerges from a shared inner mental world governed by a universal mind. The physical universe we experience is emergent from a necessary mind. This simply correlates to the idealist views of philosophy of mind. It is not matter that is fundamental and mind emergent, but mind is fundamental, and the experience of the physical world is what emerges from mind. Think of what we experience. It is a world of qualia. All we see can be described as mental without reference to any separate physical substance. It is completely impossible to describe the inner mental world in terms of physical interactions, but we can easily explain the physical world we experience in terms of qualia, shapes, forms, feelings, tastes, smells, etc. All of these are mental in nature, and the physical world itself can be reduced entirely to mathematics in how we describe it. Keith Ward says it like this: any physicist will say that brains are mostly empty space, in which molecules, atoms, electrons, quarks, and other strange particles buzz about in complicated ways. It seems as though physical objects, when not being observed, have no colors and no sounds, smells, or taste either. Sounds, like colors, are not physical events. Neither are smells, tastes, or sensations. Things do not smell like, taste like, or feel like anything when nobody is smelling, tasting, or feeling them. The physical world, it seems, is totally vacuous. No colors, sounds, smells, tastes, or sensations. What on earth is left? This correlates to what a few scientists have recently published, where they point out that there are interesting similarities between neural networks and the cosmic web of galaxies. Recently, astrophysicist Franco Vazza and neurosurgeon Alberto Folletti wrote an article on the similarities between both. Is the apparent similarity just a human tendency to perceive meaningful patterns in random data? Remarkably enough, the answer seems to be no. Statistical analysis shows these systems do indeed present quantitative similarities. They note the similarities line up with information processing, power spectrum analysis, total neuron to total observable galaxies, and in many other ways. If idealism is true, then this is readily explainable and fits with the rest of the data we have presented. Both form the same physical structure because both are emergent from an underlying mental reality. Under idealism, the brain is simply seen as the physical manifestation or second-person experience of a first-person conscious experience. And it fits with the idealist view that the whole universe would be structured in the same way, since it is also the emergent physical manifestation of mind. Thus, given the philosophy combined with the direct scientific evidence, the conclusion is undeniable. As Max Planck said, all matter originates and exists only by virtue of a force. We must assume behind this force is the existence of a conscious and intelligent mind. This conclusion has already been reached by cognitive scientist Donald Hoffman. His model argues that given all the data we just discussed, the best explanation is space-time is emergent from consciousness.
The top was the conscious agent dynamics, long-term behavior, and then if you write down the wave equation for the free particle in quantum mechanics, it's exactly the same equation. This is the non-relativistic case. You can actually read off a one-to-one mapping between non-relativistic quantum mechanics and this agent dynamics. And I won't go through it. This is the actual read-off of the equivalence between space and time and aspects of consciousness. Now, that's non-relativistic, and I'll close by the relativistic. I mean, the ultimate thing is we want to have a relativistic quantum theory falling out of a theory of consciousness, and the direction I'm going on that, and I'm starting to collaborate with Chris Fields and some others on this, is to actually take a system of two conscious agents, and it turns out it can be represented by something called a geometric algebra that I've written down there. And that geometric algebra is precisely the geometric algebra that describes the relativistic quantum free particle, massless particle. So the idea is that we can get space-time coming out of this, Dirac spinors, and ultimately, using Penrose twistors, maybe even quantum gravity. So the idea is that this program, for it to be successful, has to start with consciousness and give us all of quantum physics, and then we've solved the mind-body problem going the other way.
The paradigm is shifting, and a new consensus is emerging. The old notions of the physical world being fundamental must be abandoned in light of the new scientific data. Consciousness is fundamental, and the experience of the physical world is what is emergent. The data has been building up in several fields, from philosophy, quantum physics, neuroscience, biology and chemistry, and cosmology and holography. A new paradigm in physics is emerging, one that turns the old materialist notions on its head. We are not the accidental products of the blind workings of matter. The workings of matter are the products of the mind. The evidence leads to the conclusion our universe is an emergent world from an underlying consciousness. The paradigm is shifted, and the way we view ourselves and the universe will never be the same.